Hello, and welcome to the Tentative Tutor channel. Here's an interesting problem. Find all integer solutions to the following equation. Can you do this one? I'll solve this problem in 3, 2, 1. Let's see if we can factor. Notice the first two terms have a common factor of x squared. So we can factor out x squared. And similarly, the last two terms have a common factor of y squared. So we'll factor out y squared. But now we're left with two terms on the left, each with a common factor of x plus y. So we can apply the distributive law again and factor out the x plus y. We're left with x plus y times x squared plus y squared equal to 20. So both x plus y and x squared plus y squared must be factors of 20. Now here's our bonus problem. In this equation, can you show that both x and y must be odd integers? Leave your answer in the comments. First, we can assume that the absolute value of x is greater than or equal to the absolute value of y. Notice that x plus y must be positive. It's not equal to 1 as x and y are both odd, so it has to be greater than or equal to 2. But this means the other factor, x squared plus y squared, must be less than or equal to 20 over 2, which is 10. And that in turn tells us that the absolute value of x is less than or equal to 3. Do you know why? So the absolute value of x is 3 or 1. If it's equal to 1, that would give that the product is less than 20. So it must be exactly 3. And then since the absolute value of y is less than or equal to it, the absolute value of y must be 3 or 1. If it's 3, then x squared plus y squared would be 18. And that's not a factor of 20. So the absolute value of y must be 1. So we're left with the absolute value of x being 3 and that of y being 1. But since x plus y is positive, we get that x is equal to 3. If y were equal to 1, we'd get that the product is equal to 40. So in fact, y must be equal to minus 1, and we see a solution, x equal to 3 and y equal to minus 1. And then by symmetry, we also get x is minus 1 and y is 3 as another solution. And we can check with the original equation that the expression is in fact equal to 20. Now here's our bonus problem. For what integers x and y is x cubed plus y cubed equal to 1? Can you solve this one? Leave your answer in the comments. And thanks for watching.